This is part 2 of lesson 5.4. We're going to finish example 2 over here where we had to find the vertex form. So you would label this as a vertex form. And we also want to find the standard form. And to go from vertex form to standard form, really to go from any form to standard form, all you really need to do is expand. So what we're going to do is expand to go to the standard form. And so we're going to get y is equal to 2 times x plus 1 squared, which is really just x plus 1 times x plus 1 times itself, minus 4. We're going to do our FOIL and distribution. So y is equal to 2 times x, which is x squared. Then x times 1 is x. 1 times x, so that's plus 2x, so just add them all together there. I skipped a few steps, but you can do all the steps that you need to show there. And then 1 times 1, which is plus 1, minus 4. Then we can go and distribute everything. So the 2 will multiply everything except for the minus 4, since the minus 4 is not in brackets. So we get 2x squared plus 4x minus 2. Or sorry, plus 2, I should say, because it's plus 1. Minus 4. And I get y is equal to 2x squared plus 4x minus 2. And so this here you would label as the standard form. Standard form. Obtained by expanding the vertex form. So we found both of those. Now let's go take a look at question 3, which is more of an application style question. Find the equation in vertex form of a parabolic arch used to support a bridge. The arch is 80 meters wide at the base, and the height of the vertex is 20 meters. So let's first start off by doing a sketch. These questions here, there's several solutions you can do. I'm going to do this solution here. I'm going to draw a grid here. And I know that my parabola, my arch, so an arch is the shape of a parabola. Like if you go under a bridge, the shape is a parabolic shape. This is the arch here. Is going to be 80 meters wide at the base. So I can choose to draw my parabola starting at the origin, over here. This would be 0, 0. And if it's 80 meters wide at the base, so from 0, 0 to here, this point here must be 80, 0. And we know the vertex is 20 meters, meaning its highest point is 20 meters. Well, what is this 20 meters? When does this 20 meters happen? Well, you know the vertex is in between the two zeros. If we have 0 and 80, we're looking for the axis of symmetry. 80 plus 0 divided by 2, so it's in between these two, is equal to 40. So x is equal to 40. This is our axis of symmetry. That's the middle here. This is where the vertex happens, at x is equal to 40. So 40 meters from this 0 point, right here, you get your highest point of the arch. Or you can say 40 meters to the left of the 80 point, you get to 40, which is the highest point of the arch, 20 meters. So this point here is 40 meters, and then 20 for height. So what we just found here is the vertex. So our step 1 was do a sketch. Step 2, find the vertex using that sketch and using the axis of symmetry. And we know it's 40, 20. Now, this is our h, this is our k. So what we can start doing is making the equation. We can start saying that y is equal to a times x minus h squared plus k. And so y is going to be equal to a x minus 40 squared plus 20. Don't forget we need to find a. Do we have any points that we can use to find a? Well, we do. We have a few different points that we can use. We can use let's see, what do we have? What information do we have? We can use the point 0, 0. We can use the point 80, 0. That's one possibility. Let's use the point 0, 0 in this case. So there's two possibilities, I should say. So we'll use 0, 0. So using 0, 0, we can go plot that in. 0 is equal to a. And you could have chosen the other point, and that would have worked as well. Minus 40 squared plus 20. It should be squared here. So 0 is equal to a minus 40 squared plus 20, which means that 0 is equal to 1600a plus 20. Now we can send our 20 to the other side, or just subtract 20 from both sides, and we get negative 20 is equal to 1600 a. Now we can divide both sides by 1600. That crosses out, that crosses out. And we get, in our most simplified form, that a is equal to negative 1 over 80. So now that we have a, we can go and plug in that a into our equation here. So we get y is equal to negative 1 over 80 multiplied by x minus 40 plus 20. This is just one way to solve this type of problem. You could have also chosen to draw your parabola in different ways. You might have chosen to draw your parabola on the other side of the axis, of the y-axis, so going from 0, 0 to negative 80, 0. Some students might have chosen to do this instead. They would have drawn their grid out like this. They would have had their 20 meters at the 0 over here. They would have drawn their arch like this. And they would have said this side was negative 40. And this side was 40. 0. And 0. So it matters that you do a sketch first to show me what you're doing and what points you're choosing. So I recommend that you retry the problem using the method that we did, but also retry the problem drawing the arch in different ways. So you need to show that sketch to show where you're getting your point from and where you're coming from to really understand this idea. You could have drawn it at a random spot, so you could have drawn it maybe here and here. that the main point is that the bottom should always be 80 and the top should always be 20. So here we have 80 width and then highest point 20, and that'll help to give you an equation that satisfies the conditions in the question. So we'll start question 4. A rocket is shot in the air. Its height h in meters after t seconds is given by this equation here in the vertex form. First question is, does this parabola open from the top or from the bottom? And if you look at the a value, it's negative, so that means that it opens down. So you would just say it opens from the bottom because the a has negative. The a value is negative. What is a vertex? So vertex, you can simply look at the HK here and change the sign of the H in there. So we know the vertex is 4, 125. Now this parabola opens from the bottom. So what we know is that it's going something like this. This is the trajectory of the rocket. So what does this vertex represent? Well, it basically means it's the, at 4 seconds, the rocket reaches (125) meters. From what height was the rocket shot? So what we're asking is, where were you at time 0 when you first shot the rocket? So for C, I'm going to do that over here. We're asking you time 0. So H is equal to -5. Replace the t by 0, minus 4 squared. And doing that just made me realize I made a mistake here. Don't forget to put your squared here, otherwise you lose a mark. Minus 4 squared plus 125. So H is equal to -5 times 4 squared, which is 16, so 16 times -5 is going to be -80, plus 125. So H, the height you were at, is 45. So your therefore statement would be a full sentence, but you'd say therefore 45 meters is where the rocket was shot from. So you might have been on, maybe, here's our grid here. This x-axis is the ground. You might have been just on some kind of platform over here. You shot it up, went up, and then came back down. So you shot from 45 meters high. When did a rocket hit the ground? Well, if you think about this question carefully, it's asking you, when is H equal to 0? At what point is H equal to 0? So what we're going to do is we're going to find the t, the time, when H is equal to 0. We might have time to finish in this video. If we don't, we'll finish in the next one. But we'll get started on this. So we have 0 is equal to -5 t minus 4 squared plus 125. We'll solve by sending the 125 to the other side or by subtracting 125 from both sides, and that gives us -125 is equal to -5 t minus 4 squared. We'll divide both sides by -5. Now it's hard to see there, but that's what we're doing, dividing both sides by -5. And we get 25 is equal to t minus 4 squared.